All right, we're taking a look at number 2. This is my second time through this because I just recorded it with my mic off. All right, so trying it again. All right, we are given a function defined for values greater than or equal to 0. We're given f of 0 is 5, and we're given f prime over to the right, okay? So in part A, it says use the graph to determine whether the graph of f is concave up, concave down, or neither on this interval from 1.7 to 1.9. So that's going to be along here, okay? That is f prime. Concave up, concave down. We use our f double prime. So f is going to be concave down on the interval 1.7 to 1.9 because f double prime is less than 0 on this interval. So that's just saying the rate of our first derivative, our slope of our first derivative, you can see is negative. It's decreasing on that interval. Okay, so that's an easy one. All right, B. On the interval from 0 to 3, find the value of x at which f has an absolute maximum. So it's very, very, very important. You recognize it's asking you for an absolute. It's not asking you for a relative, okay? We know, based on our picture, where our relative maxes and mins happen. We know that our slope here is positive and negative. So right here is a relative max. Then here, it changes sign from negative to positive. That's going to be a relative min, okay? But because it's asking for the absolute maximum, we have to look at our endpoints as well. So to find those values where they cross the x-axis, because we are going to have to test the one where the relative max is, which is this one. This is going to be a relative min at that value. We have to know those values. So let's set our first derivative equal to 0. And notice you have two factors, okay? What do we do with our zero product property? We set each factor equal to 0 and solve. This can never equal 0. An exponential function won't equal 0, okay, because e to any power will still be positive, so that's impossible. But our other one is sine of x squared. That can equal 0, okay? So let's just think about, you might be thinking, I don't know what sine of x squared looks like. Sure, you can graph that in your calculator, but if you think about just your regular sine function, it's 0 at 0, pi, 2 pi, 3 pi, right? So if we know where sine of x equals 0, we can figure out where does sine of x squared equal to 0. So it equals 0 at 0. When does x squared equal 0? At 0, okay? It equals 0 at pi. So if x squared equals pi, that means our input needs to be square root of pi. It equals 0 at 2 pi, so that means the square root of 2 pi, square root of 3 pi, and so forth. We have to figure out which of those values are actually between 0 and 3. Square root of 3.14 is between 0 and 3. Square root of 6.28 is between 0 and 3. Square root of 3 point something, square root of 3 times pi, not going to be less than 3. So those are going to be our 3 values, okay? So when we go and check our function values, we need to make sure that we're checking our endpoints, which that was actually a critical value. 3 was not. And then the values in between. Now, we don't need to spend time finding this one because we realize it's a relative min. This is a relative max. These are our endpoints, okay? So our absolute max is going to happen at this one, or this one, okay? We know f of 0 is 5. We don't know f of radical pi, and we don't know f of 3. So we're going to have to use our first fundamental theorem of calculus to help us. So we know that the integral from 0 to square root of pi of f prime equals the function value at pi minus the function value at 0. We're going to use our calculator to calculate that integral, and that is going to give us 0.679 equals the function value at square root of pi minus the function value at 0, which is 5. So that's how we get our function value at pi. It's 5.679. So clearly we can see right away that that is higher than 0.5, okay? We also have to find the function value at 3. So we're going to do our interval again, our integral again, using our first fundamental theorem of calculus. We know that the integral of a derivative just equals the function value minus the function value of your lower bound, okay? So we'll use our calculator to calculate that integral, and that gives us 0.579. That equals f of 3 minus 5. I now add 5 to both sides, and I get my function value at 3. And it's 5.579. Okay, so which one is our absolute max? It's this one right here. The question is asking you at what x value. Didn't ask you for the absolute max value. It just said when does it, it's asking for when it happens. So we will say the absolute max happens when x equals square root of pi. And you need to justify your answer. Your table is showing that you've tested your endpoints, and your critical values in between, okay? All right, part C, write an equation for the tangent line at 2. We don't know our y value at 2, okay? So for part C, you're going to have to do your integral again. 0 to 2 of f prime. That's going to equal f of 2 minus f of 0. When you do this integral, you end up getting 0.623 equals f of 2 minus 5. So we know our function value is 5.623. So our point is 2, 5.623. And we need to find our slope. So our slope will be f prime of 2. So plug that in up into the function e to the negative 2 over 4 times sine of 2 squared. And your slope will be negative 0.459. So when we go to put this into point slope form, looks like that. If you want to just write it as y equals, we can move that 5.623 over. And there you are. Okay, so let's just go through the rubric so we can see that we got a 9 out of 9. Okay, so for the first one, we say that it's concave down, so we got a point for that. And the reason I put that f double prime was negative, so therefore we know it's concave down. They wrote f prime is decreasing, giving us the same information, okay? Because it's the slope of the slope is negative, right? So part B, you get 1 point for identifying radical pi and 3 as your candidates. So we have f prime of x equals 0. At all those values, changes from positive to negative only at radical pi. So remember how we talked about that? So therefore, we know our absolute maximum must occur at that radical pi or our endpoints because of EVT. So remember, if EVT, if you have a continuous function, it guarantees there will be an absolute maximum and minimum on a closed interval. And that's why we have to test our endpoints, okay? So that was 1 point, which we did. Okay, I had it set up in a table. Your next point, you're going to show that f of square root of pi is greater than the function value at 3, which we did because we went through and found it using integrals. And then our answer is radical pi. And again, that's just showing, showing that that's happening. All right, next up, question C. Write an equation for the tangent line. They give you an equation they give you 2 points for the expression to find f of 2 using your integral and including the given f of 0, which we did. And then you find your slope, and then you find your equation. So we checked off all 9 parts for this problem.